This is the solution to a warm up from 3.1, where we're going to analyze a quadratic function in general form. So we're given a quadratic function, which is f of x is equal to negative x squared plus 8x minus 14. And the first thing we're asked to find is write the function in a standard or vertex form. So I'm going to do this in two methods. So the first way is I'm going to complete the square. And the second way that we can do it is with the backdoor approach, where we will find the vertex and then use the vertex to write the function in vertex form. So let's first begin by, we'll do it by completing the square. So I'm going to write the function. So f of x is equal to negative x squared plus 8x minus 14. So when we complete the square here, we're going to take the first two terms, the ones that have x in them, and we're going to factor out the coefficient of the x squared term. In this case, it's negative 1. So I'm going to factor out that negative 1. That'll leave me with x squared minus 8x. And then I'm going to just move the constant term off to the side. I'm going to write minus 14. Now we're going to complete the square inside the parentheses. So here, when we complete the square, the magic number that we add is going to be b over 2 squared. So in this case, b is negative 8. So I'm going to do negative 8 over 2 squared. So that's b over 2 squared, which is negative 4 squared. And negative 4 squared is 16. So we need to add 16. When we completed the square in the past, we added 16 to both the right and left sides of the equation. In this application, it's easier to first add it and then subtract it, or vice versa. So here we added 16 inside the parentheses, but we need to be a little bit careful because we have this negative out in front, which means what we've really added is the opposite of 16, which will be negative 16. So that means we really subtracted 16 from the right side, which means we need to add 16 to the right side. The net effect is that we haven't changed the equation at all. Okay, now we are ready to rewrite the perfect square trinomial that we created inside the parentheses as the square of a binomial. That's going to be x minus, because we have minus 8x. And then the value, the constant that we subtract here, is half of the middle term, so half of 8, or the square root of 16. In both cases, that'll give us 4. So we have x minus 4 squared. Plus 16 minus 14 is plus 2. So this is our function in vertex form. Okay, let's do it by the backdoor approach. The backdoor approach means let's find the vertex. So the x value of the vertex is going to be always negative b over 2a. Here b is 8, so we'll have negative 8 over 2. A is negative 1, so negative 8 over 2 times negative 1 is negative 8 over negative 2, which is positive 4. So the x value of the vertex is positive 4. To find the y value of the vertex, you're going to substitute the x value into the function. So we're going to find f of 4. So f of 4 is negative 4 squared plus 8 times 4 minus 14, which is negative 16 plus 32 minus 14. So that is negative 30 plus 32, which is positive 2. So our vertex is 4, 2. And now we're going to use vertex form. So we know the vertex form of a quadratic function is a times x minus h quantity squared plus k. So here, a is the same value that it was in the original function. So a is going to be the same thing as it is here, which is negative 1. So I know that, so I'm going to write that down in my function. So negative. H is the x value of the vertex, so that's x minus 4 squared, and k is 2. So this is h and k. And we got the same value, the same function as we did by completing the square. Okay, now we're just going to do the other portions. So stating the vertex, we actually found the vertex in our backdoor approach, but we can also just read it from vertex form. So the vertex is the point 4, comma 2, right? Because this is H and that's K. And then next we need to find the x-intercept. So to find the x-intercept for any function, we can simply let y equal 0. So, and solve for x. So we're going to let y equal 0. It's easier to find this using vertex form. So we're going to put 0 is equal to negative the quantity x minus 4 squared plus 2. We will move the 2 to the other side. So negative 2 equals negative the quantity x minus 4 squared. Divide both sides by negative 1. So 2 is equal to the quantity x minus 4 squared. Take the square root of both sides. Don't forget the plus or minus. So now we have x minus 4 equals plus or minus rad 2. Adding 4 to both sides, we get x equals 4 plus or minus rad 2. And if we're going to write these as x-intercepts, write them as an ordered pair. So the x-intercepts are 4 plus or minus rad 2 comma 0. That is part C. And then part D asks us to find the y-intercept. So find the y-intercept. To find the y-intercept for any function, you let x equal 0 and you evaluate. So we can go back to our original function and find f of 0. So that's going to be negative 0 squared plus 8 times 0 minus 14, which is negative 14. So the y-intercept as an ordered pair is 0, negative 14.